And we are in the middle. So I will open again the file. And the file is this test2. We have already included the list of the index of PV bus and PQ bus, because we decided to classify the nodes as PQ bus, PV bus, and also a slack bus. In this particular case, there are two PQ buses in two nodes in which you fix the active and reactive power, bus 2 and bus 3, and for sure bus 1 it is the slack bus because it is the only bus in which there is a generator. So we decided to call IPV the indexes of PV buses, in this case will be empty, and the PQ bus, IPQ, it is the list of indexes that are selected as PQ. This information was included in the object class bus, so the object bus, and we said if the bus type is PV, then append in IPV. If the bus type is PQ, append in IPQ. If it is the slack, append in the slack. So at this point we have the list of the buses, and we have already instantiated the lines with these values that appears to be correct, and also the buses. Take into account that in these two buses, bus 2 and bus 3, there is this absorption of power, so we have included here the power with minus because it is a load. And the slack bus says the problem that the voltage is 1.05, so we put 1.05 here. At this point, the algorithm is quite the same, but with the exception that the equations are not more 4 equations just for the case of a single line, but there are more equations because we have three buses. So how many equations we need? Probably there are 3 buses, so the voltage and angle for each of the 3, it is 6, so 6 variables, so 6 equations. Instead of writing now 6 equations, we use a for loop in order to write the equations for all the buses in which it is fixed the power, active power, all the buses in which it is fixed the active and the reactive power, and for the slack bus. So if you agree, we can implement this loop for in order to write the equation of the first equation, that is an equation for the power for all the buses in which we fix the power, that are the PQ buses and in general also the PV buses. So we can include an additional list here that we can call IPV IPQ. That is the summation of the list IPV plus IPQ. So in this way, in this list IPQ, PV, PQ, we have all the buses in which we fix the active power. And the first equation here, we can say that it is not related to receiving on or sending. No, this is the receiving bus in the previous, so we can eliminate. We can say that this is inside our list I said PV, PQ. I need to write in the same way as before. But this needs to be one of these, so I need to include a for loop. So I can write before this a for loop for I in, and then range for all the elements of I, PV, PQ. I'm closing the parentheses. I will try to close the parentheses, and then column, and then we can do this for the elements of I, PV, PQ. So now K goes to the first index, the second index, the third index of this list. And here there is an error. The error is that after this column, we need an indent to say to Python that we are inside the for loop. So we cannot write in this column, we need an indent, so I will just put a tab, and I put an indent, and obviously also this equation. This equation is for all the indexes, so I. Do you agree with this? If you agree, we can repeat the same concept also below, just for the reactive power. You see, imaginary. So just the reactive power. So we fix the reactive power. We write this equation that is the residual, the error for the reactive power, just for the buses in which we fix the reactive power, that are the PQ. And I will do the same as before, saying that K, it is this index here, so I, PQ. And here we need to enumerate. If I'm writing I, there is the risk, or I mean certain, that we rewrite the equation that we have written before. So I need to put here something that shifts this equation as many as the first equation. The first equation, how many are? I mean, are all the buses minus 1, because there is the slack bus. We fix, or we can also say N, PQ, and PV. So we can also write here as NPQ, and PQ was the number of buses that are defined as PQ buses. So NPQ plus NPV plus, and then I, the new index. If I'm writing here this, I need to define what is NPQ and NPV. So I need to put probably also here, we can say that NPV, it is the length of IPV, and NPQ, it is the length of IPQ. So it is the number of the buses that are considered to be PQ and PV. And I put here, you see, in the range IPQ, K is this index, and the number of buses PQ, PV will be 0 in this case, but we put, and plus I. So we don't rewrite, we don't replace what we have calculated just before. We do the last thing also for the slack bus. And for the slack bus, we can say that K we have introduced here, we need to modify also here, because there is already, again, the I sending, I receiving. So in the arguments, we need to know I, PV, I, PQ, and also the slack. So this information is needed. So here below, we can say, okay, we need just to write the two simple equations for the slack. So we can say K equal to slack, the first element of the list, that is the unique element, and then we can say that The equation, now we need to number so we have put NPV plus NPQ equation just for the active power, and then we have put the NPQ equations for the reactive power. So sorry, I was too early, because I prefer to be in order. So we fix the active power in the buses PV and PQ. We fix the reactive power in the buses PQ, but we need also to fix the voltage in all the buses PV. So before going to the slack, I will just put another 4 in the range of IPV in order to fix the voltages in the PV buses. So K IPV I, and then the equation is the same equation that I was writing just for the slack bus, but it is just for the PV bus because we fix the voltages. So this is NPQ, NPV, NPQ plus I, because we don't want to rewrite the equation that we have already written, and then we fix the absolute value of the voltage equal to the set point of the voltage. Finally, we can write these equations also for the slack bus. So for the slack bus, NPV, NPQ, NPQ plus NPV, and we set the voltage, and we set also the angle. And the angle is this one, in which I don't want to rewrite the equations that we have already written, so we need to put here A plus 1 and the angle. Do you have any questions so far? Because apparently I have modified the problem in order to replace the indication of sending and receiving with PQ and P. I don't know if need any help. I can also try to see if it is shaved. Okay. When I'm saving, it says in solution F solve, we have changed the arguments. Instead of sending and receiving bus, we have put the list of PQ and PV buses. So we can just replace here IPQ, IPV. Apparently there are no other issues, and then we will see running if he is finding any solution. We will see. Did you try to yes, good, very good. There is an error. What is the error? These objects cannot be interpreted. Oh, I need to see. Okay. So, as an integer. So, 84 in equation in range IPQ PV. So 84, it says that, and then we will see if we are able to find the reason, but apparently it is IPQ PV For in range, yes, in range I cannot put the list here. The range wants a number in the range of 5, 0, 1, 2, 3, 4, not this. So we cannot put this, but we need to put the number exactly. So NPV plus NPQ. In this way, we have that here in the parentheses of range there is the number of elements of the list, and since that is the list is the combination of the two, we can put here. And then we use the list in order to take our element. So also here, instead of range IPQ, I need to put NPQ, that is the number of elements in this list. And also here NPV. I'm trying again to see if you see that we have printed during in the equations, we have printed at the end the equations. And we know that the solution is when these equations, this residual goes to 0. You see that at the beginning it doesn't do nothing and then starts to operate. So all these numbers are a little bit big at the beginning and then start to reduce. And then at the last iteration you see that these numbers are all 0. You say, oh, they are not 0, there are numbers, but you see that there is e minus 11, and this means 10 raised to minus 11 or minus to 23. So it is extremely low. It is lower than the tolerance of your computer. So I say that these numbers are 0, so you reach the convergence, and we can see if the solution is reasonable. And the solution, you see that you have the voltages in modulus and angle. This is for the slack bus, so it has not changed. These are the voltages in bus 2 and bus 3. So we can see here bus 2 and bus 3. And then you have also the indication of the power that is flowing in these branches. So it is in per unit. We have divided by 100. So there is 199 megawatt that is flowing in this branch between 1 and 2. And between 1 and 3, it is going to 210. So these two flows goes to 1 and 2 and 1 and 3. In 3 there is this consumption, and then some power is going from 3 to 2. From 3 to 2, it is 0.066. So you see that when you go, the power goes to from 1 to 1, from 2 to 1, it is negative because it is a flow in the other direction, and also the flow between 2 and 3, it is negative because 3 to 2, it is negative because it is in the other direction. You see that there is a difference between the power between 2 and 3 and 3 and 2. There is a difference, so also the difference between 1 and 2 and 2 and 1, they are negative, but there is also a difference. Well, why there is a difference? Because there are the losses into the network. So the power at the beginning of each branch is not exactly the power at the end. And you see that at the end we can also calculate the power in the nodes. the power in all the branches. Do you have any question so far? So perhaps we have solved the problem of the three nodes, and now I can share this file to you, and we can also try to use this algorithm also to calculate the power flow in a larger network, little bit, with respect to the three buses. So instead of this node, we can go to the example of 14 bus. This data is composed by a part in high voltage, this part, and you see 69 kilovolt, and this part here, it is 13.8 kilovolt. I will share to you just this file so we can use it. We can also complete in some parts, so I will try to do this. And now I would like to use this for this network, that is not this one, that is simple, but this one. And you see that there are many buses, many lines. So we have several data. You are here, all these data with two, we can say, matrices, one for the buses and one for the lines, the resistance, the reactance, and so on. And we cannot now typing all these data here. So it is the typical problem when we do some calculation in power system, in that the data are quite a large amount. No? So I will try to take the data directly from the files. I have shared the files with you. I don't know if you received the CVS files. This table, I put this table simply in Excel, and I extracted the file as comma separated value. And I will try to import directly the data from the comma separated value files by using the tool that is called pandas, that is in general used in Python in order to treat the data. Pandas can also directly read Excel, so if you have an Excel file, but I prefer here to use the text file, because so we can see also the data. So I don't know if you have already received the CSV files. If you have, I mean, you can import directly your file. We can go in the file scheme here, the table tab, the tab of the files, and I put here. Here are already there, but in order to upload the file, just click in upload the file. If you have the file in your computer, and these are the two files that are shared in the WhatsApp. So you can import these files, and we can also see the files here. We can also open here. If they were Excel, we cannot see in Python, but we can see here because they are comma-separated value files, so they are text. So this is for the branches, and so the file, it is for all the branches that are numerated in the first column. So 1, 2, 3, and so on are the number of the branches of this of this network. So and then the second and third column are the sending and receiving bus for each branch, so the configuration, and then the resistance, reactance, the total shunt admittance of the line, and then there is the transformer ratio. How we put the equations? We put the equations thinking that we can say the tap changer is in the secondary side, but the data are provided in the primary side. So I put just 1 divided the ratio, so 1 divided by A, because this is the scheme. So this is the change. So this is 1A, and then there is also another file that is for the nodes, and for the nodes we have in the first column the number of the nodes, so they are 14 buses, and then the type, if it is 3, it is the slack bus. It is the IEEE standard, so it is 3, the slack bus, and then 2, the PV buses, because there are generators, and also synchronous converters, and 0 are the PQ buses. And then there is the load in megawatt, in M-bar, the generation in megawatt M-bar, and also the voltage, and at the end some capacitor banks.
So the type is 1. The type is equal to 1. What bus it is? Type is 1.
But there are no 1. There is no.
So, yeah. You define 1 equal to 3 is for slack bus.
The slack bus, 2 it is PV
bus.
And 0 it is PQ.
What about 1?
We don't have any other type of buses than this.
Because 0, 2, 3 you are using, not 1.
Yeah, probably yes. But I don't know. I've just taken the data from that are available for this, and the type of buses are these. So we can classify the tree. So we try to now to use this. I would like to copy our test2py in a test tree, so we don't modify this. Open, and I open the bash console, and I will copy this test3py in a test2. We have test2py. I copy in test3.py. So I do apologize. We need to copy this test2py in test3.py. So we have this file here that we can modify without changing the original file. And now the thing that we need to do at the beginning is to try to use this Panda tools so that we can import directly the data, avoiding to typing. So import pandas, and in general it is imported as PD. So I'm saving, and it says that pandas is imported but not used. So apparently he recognized that pandas is already installed. So if it is fine for you, we can maintain the pbase as this. These are not needed, so we can also delete in order not to make confusion now. The vbase and so on, because they were for the first example. We have already commented the sending and receiving of the first example that we saw. For the objects, I have no changes to do, because we have already considered as the ratio. And the thing that we need to change, it is the definition, the implementation of these elements, because instead of writing here, we need to read from our files. So in order to read from the files, we can write in this way. Probably this can be commented or deleted as you prefer. Commented with the hashtag in the first column, and then we can say df, and we can say, for example, the branches. I say R, it is PD, our pandas, and then we need to read. So we read, and we read the CSV file, so we put the CSV. And then the name of the file, and for us the name of the file is 14 pass underscore branch dot CSV. We need to put the apostrophe before and after, because it is the name of the file. In this way, hopefully we have read the content of the branch, and we can also read the content of the nodes. So I put this, pandas call these matrices as data frame. So I put df instead of r, I put n, and these are the nodes, the node. At this point, I'm not sure if we are able to read good these files, because it is always tricky, this reading. So I would like to check. But checking, it means that we do all the procedure. I would like to just to stop the procedure here. In order to do this, we can comment directly with a single instruction all the instruction below. And this can be done by just 3 dots. So if you put 3 dots here and 3 dots at the end, you have commented all these instructions. Is it true? Probably not, because it is, probably I'm wrong. That is better. Not 3 dots, but 3 apostrophe. So with the 3 apostrophe, we have commented all the lines below this. So I can try to run and see whether we are able not to read these files. It doesn't complain, so it is a good sign. And then I put df underscore r, and you see that in this data frame, dfr, there are the data that have been imported from the file of the km buses, the resistance, reactance, and so on. And also df underscore n, df underscore n, it is the matrix of the data of the buses. So far, so good. Do you have any question, any problems? Apparently, you have also. Okay, so we can take out the comments here for the rest of the part, and just see if we need to put, we need to put some instruction here in order to instantiate all the lines and all the buses together. So I will put just a for loop, and and then I say I in range, and then we can put here the length, and the length it is for the data frame R, so df R. And we need to choose just a column for this data frame, and I am choosing for R, there is for sure the column of the first bus, so bus K. So I will just put in the column here between brackets the column K. We need to put in, so it is just how many rows there are in this data frame. I will close this parenthesis. Probably I need to close another parenthesis, and then the column. So we are in to all the lines of this data frame from the branches. And then we can say that node K, it is equal to the data frame, the branches in column K. Okay, and it is the row I. So open another bracket, I, close the bracket. We repeat this instruction for all the other information that we need to store in our code. So node M, so the column is M. The information that is the impedance, so we can say ZKM, that is given by the data frame in column R, and then Control C, the 1J, so we can say 1J times the data frame in column X, so the reactance, the resistance plus J, the reactance. We need to write always 1J, not only J, because otherwise J is taken as a variable, instead here as a meaning of the imaginary part. We can also write here the, I will copy again, AKM, that is the ratio of the transformer, that is given by this 1 over A column, we call it I. We have seen that in this column, when it is in the column 1/8, in this data, I will try to open again this, we are reading this. You see that in the last column, when it is aligned, it is 0. But for us, when it is aligned, the ratio needs to be 1. Because, so we need to convert 0 and 1. We can do here. Do we have some time still? Yeah, good. We can say if AKM is equal to 0, then, so I put the column, and then AKM is equal to 1. I do apologize. We need also to take into account this 1 over A. So we can say when AKM is greater than 0, we can say that AKM is equal to 1 divided AKM. Otherwise, else, and so when it is 0, and else there is also the column AKM is equal to 1. So in this way, we have replace the ratio, extract the correct ratio as we have considered in our algorithm. And then we have the last thing to extract from our data frame, that is the YKM shunt. So YKM shunt, it is equal to the data frame, and it is in the B tot column. So it is this B tot here, so it is written as B underscore tot. And it is the total, but we have divided in the two columns of the, so we are in this here, these admittances are half of the value that is provided by the data. So we divided by 2. So here it is divided by 2. At the end, in order to instantiate, we need to call our object, that is branch. So we can avoid to include this object in the list branch here. So here can be commented, and we can include this instruction instead of inside of the object here in this for. So we can say, okay, we install this object in our system. So we can say list branch append, and what we are appending? We are appending our branch. So it is written as branch, as we did with the three bus system. So branch, and open the parentheses and all the elements. I will go directly to the object and take directly this information from here. So Ctrl C, Ctrl V. Node K, node M, ZKM, YKM, shunt, AKM. Is it, I don't know if it is good or not, but we can run. We can put a comment as before here. also here below, just the comment of the rest, and see if running it gives errors in doing this. There is an error that is divided by 0. Oh, in AKM, oh yes, because AKM greater, not equal to 0, greater than 0, otherwise there is the division by 0. So apparently there are no errors. So I can see in the branches if there are our objects. So you see that there are many objects. Hopefully there are as many objects as the lines of our data frame. We can also do the same for the nodes. So we repeat the same concept also for the nodes. So in this case we go from, I can copy just the first and then modify. For I need to start from the first column because we are outside this 4. So the 4 in range data frame in nodes. Also there is the bus K, and then we can start to write the instruction in order to extract the information from data frame. So node K, it is the data frame of nodes in bus K, and then we can say that if the data frame in node of and the instruction here, the column, it is called VRMS set. You see that in many cases this is equal to 0 because they are not provided. So we need to say that if this value VRMS set is different from 0, so we close the bracket for row I, it is greater than 0, then we take this Vk as the complex number. We can also use the instruction complex, open and close the parenthesis of this DFN V set, so the voltage here equal to 0, and the imaginary part equal to 0. This is the same as saying this is the real part and 0 the imaginary part. And then we can say else, and then column, and then we can say that if it is 0, we can say that is just complex 1, 0. So 1 the real part, 0 the imaginary part as the initial solution for the power flow. We can also include SK as this value here, but the power is in the column generation megawatt, and in the column load. They are separated in 2 different columns. So for us, the power at the node is the net power. It is the difference between the generation and the absorption. So it is generating minus load, that is the load. And then we need to say also the reactive power. So we can say plus 1J, and then product, and in parentheses we can write the same instruction, so generation and minus the load. Load needs to be written correctly. And then here in parentheses there is no megawatt but mvar, and this here is in var. We have seen that we divided the power from P base in the object, so we don't need to divide here because our object takes already the megawatt. The last thing that we need to say, it is the type of node. So we said that if the node type here, it is type written in this way, so we can write type. If the type is equal to 3, then our bus type, so the object has a bus type here, our bus type needs to be equal to saldo, or slack, I don't know. Slack. I need to correct also one thing here. Instead of SK, in the objects we have SK MVA. So we put here SK underscore MVA. And also for VK, we have put here VK underscore P per unit. So it is VK underscore per unit also here. We need to be in agreement with the definition in our object. And then we can say elif, if this bus type is equal to 2, then we can say that our bus type is equal to PV, and we can say at the end else the type, bus type, is equal to PQ. Then we can append, there is also the YK shunt. YK shunt was not included in our object, so we can include now as Y shunt, that is the capacitor bank. In the other problems we don't have the capacitor bank, Y shunt, and we can put here, we can comment this append because we will do just after, and we can include also this self dot Y shunt here equal to Y shunt. So in this way we can include this instruction here, that is Y shunt equal to the value in the column, that is B shunt, the last one, BSH, but take into account that this is not the admittance, this is just the imaginary part. So if we wish the admittance, we need to write 1J times this value. At this point we can append, so we can replace this list bus append self with an instruction here, obviously inside the for, and inside the for we can put the instruction that is our object is bus, so it is bus, and the arguments are all these that we have taken from our data frame. So these are our arguments here. I will try to run to see the errors that I made here. List append, I made a mistake, I do apologize. I cannot write in this way. We need the list append, bus, and then this. So this is the object. I missed the object. So it is our object that is here. So save, run. So bus, open parentheses, all the arguments of the bus, and so on. It does not complain, so hopefully in the list bus there are all our objects. Hopefully they are all the nodes. Going around, if you have any question, please let me know. Go down the Y matrix. Do we need to modify something in Y matrix, in the Y matrix? I think the only thing that we need to modify is that we have a capacitor banks in some of the nodes. So the Y matrix, the admittance matrix, needs to include also the capacitor banks. So we have here some nodes in which there is this YK shunt. We have not included until now because we have included just the elementary admittance matrix of all the branches. We need just at the end include the capacitor banks. So we can say here for I in list, we said that it is list bus, and then column, and then we need to say that the elements of the admittance matrix in the diagonal in the node k minus 1, because Python starts to count with 0, it needs to be added, so we plus equal our I Y shunt, that is the shunt element of the capacitor bank. Hopefully we have now the rest of the system. That I will try to run to see if it is able to run and what are the errors. So the error is that the bus object has not attribute YE. I need to understand why it is doing what I have done here. Bus object. Oh, in the list branch, instead of appending the branches, I appended the buses, so that was completely wrong. So instead of the bus, I need to change bus with branch. So in the list of the branches, I need to include the branch. So hopefully now, okay, apparently he has found the solution. And you see that there are the the voltages and then also the power flow in per unit in each branch of our network. I would like just to check where if the slack PV and PQ are taken into account properly. So I will just check the slack bus. It is easy because for the node in the slack bus it says that it is 1.06 the voltage, and our solution it is indeed 1.06 0 degrees because it is the slack bus. And then it says that in bus 2 and in bus 3 and also in bus 6 there are PV buses. These are not all the generators. There in bus 1 it is the slack bus, so it is a generator. Bus 2 it is a generator. In bus 3 and also in bus 6 and also in bus 8 there are synchronous compensators that are not equipped to provide active power, but they fix the voltage. So they are treated as PV buses with P equal to 0 and the voltage fixed as mentioned here. So we can see, probably in here it is more clear, it is 1.045, 6 it is 1.07. So 2 is 0.45 and 6 it is 1.07. You can also check 1.09 in for this bus here. So apparently is taken into account. I would like to check just the results if there are errors around or not. Apparently the results are in agreement with the expectation. Yes. You see here the iterations that are made, and this is the admittance matrix. We can also try to calculate at the end, if you wish, the power in the slack bus. So we can also add an instruction at the end that makes the power injection in the slack bus. But probably we are running out of time, no?